Bismillahirrahmanirrahim. My name is Dr. Amber Arshad, and today my topic of presentation is two sample hypothesis testing under supervision of Professor Dr. Sara Afzal. In this presentation, I shall be explaining measures to consider two sample test used for two sample measurements of mean, variance, median, independent sample t-test, pool variance t-test, NOVA, F-test distribution, and F-test and the F distribution. At the end of the presentation, the participants will be able to describe how to use hypothesis testing for comparing the difference between the means of two independent populations or groups, or the samples, the means of two related populations, and the variance of two independent populations. So whenever we are testing the two samples, so we consider the population means of the independent samples. For example, group 1 versus group 2. Or we can use population means of the related samples. For example, single group pre-test, post-test, and the population variances. For example, variance 1 versus variance 2. So whenever we are using the two sample testing and we are using the numerical data, we come up to this flow sheet. When we are considering the means, we go for the two tests, that is the pool variance t-test and one-way ANOVA. For the variance, we use F-test for two samples, and for the median, for the two samples, we use Wilcoxon and for comparison proofs as well. If we are studying one group, used a pair t-test, but for the two tests, we always use the two sample t-test that is most commonly used, and it can be and usually we use the two-tailed test. So the two sample t-test or the independent t-test is the most commonly known t-test whenever we are considering the population means of two groups, either they are equal or not. We have to see it by the values of the t statistics relative to the critical value that is taken from the table. The assumptions for the test is both groups are sampled from normal distribution with equal variances. And in order to run an independent test, one independent and categorical variables that has two level groups and one continuous dependent variables are necessary. Does the t-test use categorical variables? They can be used to test the effect of a categorical variable on the mean value of some other characteristics. And t-tests are used when comparing the means of precisely two groups, like average height of men and women. In such cases, we can use t-test. And when the population variance is unknown and the sample size is greater than 30, then we mostly prefer the z-test. So considering the difference between the two population means, we consider this scenario first whenever we are using the independent samples. So the goal for testing the hypothesis is, or for the confidence interval for the difference between population means, is mu1 minus mu2. And the point estimate for this point estimate of this difference is x bar 1 minus x bar 2. Difference between two means independent for the independent samples, the unrelated and the independent samples. Sample selection from one population has no effect on the sample selected from the other population. And for this, we use either a pooled variance t-test in case if the assumptions is that the sample is having unknown standard deviations, but the variances is assumed equal. And in second scenario, if the standard deviations are known and are unequal, then we use a separate variance test. But considering the first scenarios, we use the unrelated and independent samples. In this case, the hypothesis for testing, it can be of three types: lower tail test, upper tail test, and the two tail test. For the lower tail test, we consider the null hypothesis that mu1 is greater than equal to mu2, and in the alternate hypothesis, mu1 is less than mu2. For the upper tail hypothesis, we consider that the null hypothesis that mu1 is less than mu2, and alternate hypothesis is that mu1 is greater than mu2. And for the two-tail test, we consider the null hypothesis mu1 equals mu2, and alternate hypothesis mu1, that is mean of one sample, is not equal to the mean of the other sample. So in this case, if for the lower tails, we reject the null hypothesis if t statistics that is calculated by implying the formula. We can also use SPSS for that, and is less than the t a critical value, or in the upper tail t-test we reject the null hypothesis if t stats is greater than t alpha, and in two tails test we reject if the t statistic is less than minus t or t stat is greater than t alpha by 2. Now here we have alpha by 2 because it's a two tail test, so we have divided the total alpha into two parts, so it is alpha by 2 in this case. For example, we can use a dependent t-test to understand whether there was a difference in smokers' daily cigarette consumption before and after a 6 weeks hypnotherapy program. In this case, the dependent variable was daily cigarette consumption, and your two related groups would be cigarette consumption values. There is also an option if we are using a simple sample, so the single sample, and we are using observations for a single sample at two different times. Then we use a paired t-test, not a independent sample t-test. In this case, we are interested in the difference between two variables of the same subject. So this should be differentiated at first. For example, we use Dixon and Macy's data for cholesterol levels in 1952 and 1962 for each subject. So it could be, so this will be a paired difference test rather than a simple t-test. Another question is that should I use a Wilcoxon or a t-test? Students' t-test is a test of comparing means, while the Wilcoxon's test orders or is for ordering of the data. For example, if you are analyzing the data with many outliers such as individuals' wealth, where few billionaires can greatly influence the results, so Wilcoxon test can be more appropriate rather than the student's t-test, or it's a non-parametric test. So it's an alternative non-parametric test. Alternative for t-test is the Wilcoxon test, and when we are considering the ordering of the data, and this test is based on ranking from the smallest rank to the second to the third, and so Wilcoxon sum test is the sum of the ranks of observations from the samples. Variance is very important tool in science in building the statistical science, and in theory the probability and statistic variance is an expectation of the squared deviations of a random variable. It is the under root of the and the under root of the variance is known as standard deviation. Now we consider two scenarios if the variance is equal and variance is not unequal. What does the relative equal variance is equal means? That in one sample variance is no larger than twice the size to the another. That you can assume that the equal variances are there. So in the start there were two scenarios when we are testing the hypothesis for two samples with equal variances and unequal variances. So for the equal variances, the difference must not be twice as the size of the other between the two variances. And since equal variances is also known as the homogeneity of variances, so statistical test, for example, the analysis of variance assumes that variances are equal across the groups and the samples. What is a pooled variance t-test? Actually, whenever we are using two independent populations and they are having an equal variance, so we use this parametric test procedures with having the assumptions that the sample is randomly taken, is taken from the random population, and the population is normally distributed. And if not normal, then can be approximated by the normal distribution. And population variances are unknown but assumed equal, as I have explained in the previous. What does equal variances means? So in a common example of pool variance t-test is that growth of pine seedlings in two different substrates was measured. And if you want to know the growth was better in substrate 2, growth in centimeter in years was measured and included in the table. And for I am not going into the calculations, but simply we take the alpha 0.05, we calculate by applying the formula of t-test. If the t critical value comes less than, if we are using a single tail test, then if it comes less than the minus t value from the table, and we always compare the value, and from the previous slides we will interpret if the values have difference and we will decide the significance. This is a simple explanation where we are considering that HO is a two-tailed test, since we are using a null hypothesis of mu1 equals mu2 and H is mu less than mu2. So in this we used a subtrate, and there was a after calculation the t stats was -66 and the critical value was 1.17. And the confidence interval approach for variance was used, and it was decided at 90% confidence interval with degree of freedom. All negative values tell you that there is a significant difference between the mean growth of the two subtraits. So it showed that the substrate 2 has significantly, substrate 1 has lower growth than substrate 2. So this all depends on how our t-test values comes and compared to the statistic value. So test statistic is less than the critical value. So in this case, we will reject the null hypothesis. So in this case, considering the second one, you are testing the hypothesis between the difference of two means considering the unknown standard deviation but assumed equal. The assumptions are that samples are randomly drawn and independently drawn. Populations are normally distributed and at least the size of 30. And population variances are unknown but assumed equal. In this case, for the hypothesis testing, the pooled variance test or the t-statistic test is applied. And the confidence interval is also calculated. And for this, f-test is used whenever we are comparing the variances of two populations that are considered equal. So this f-test is can be one-tailed and two-tailed, and the two-tailed version tests against the alternative that the variances are not equal. So whenever we are using the two-tailed, we are going into this second scenario. But for the first scenario, we are using the one-tailed test. While t-test is used to compare two relative samples, f-test is used to test the equality of the two populations based on variances. So should I use f-test or a t-test? That is the next question. So the t-test is used for small samples as the test of significance for single means and the difference between the two means, that is the related or independent samples. While the f-test based on the ANOVA is used to compare means between multiple samples or more than two samples. So this is the assumption or this is the condition. We use mostly ANOVA if we have more than two groups to compare, more than two, and we have to check the equality. So we consider the following conditions that one nominal scale is independent variable or two or more treatment levels of classifications, and one interval or ratio scale dependent variable used to analyze completely randomized experience designs. One-way ANOVA test with f-test assumptions has randomness and independence of errors, is independent random samples are drawn and the normality and populations are normally distributed. These are the assumptions. And populations have equal variances, meaning that both variances don't have a difference of twice as size of the second variance. So ANOVA uses f-tests to statistically test the equality of means. Whenever we are using one-way ANOVA, we have collected the data about one categorical independent variable and one quantitative dependent variable. The independent variable should have at least 3 levels or at least 3 different groups or categories. Unfortunately, simulation studies find that the assumption is strict required. If your group have unequal variances, your results can be incorrect if you use the classic test. On the other hand, Welch ANOVA isn't sensitive to unequal variances. So in this, an alternative for this is the Kruskal-Wallis test, which is a non-parametric approach. And this procedure is used to compare 3 or more groups on a dependent variable that is measured at least on an at least an ordinal level. So this is the non-parametric alternative for the ANOVA, one-way ANOVA. We also use the Levene's test that is used to test if K samples have equal variances. And we can also use the chi-square test that can be used if the variances of the population is considered equal to a specified values, but both the variables must be categorical for applying this chi-square test. And the last is that one hypothesis test for mu1, mu2 with unknown standard deviations but or variances and not assumed equal. So for this case, the samples again are randomly drawn, populations is normally distributed, similar assumptions, but the test we apply are different. Here we also use the t-stats and the degree of freedom, but we use a modified version of t-test to identify the population means for the variation where variances are not considered equal. So f-test compares the variances. Here the two-tailed version of ANOVA test against the alternatives that the variances are unequal. So the two-tailed ANOVA version is specified whenever we are going for the this assumption that the variances are not assumed equal. And this tool executes the two sample students t-test on the data of two independent populations with unequal variances. But sometimes the overrepresentation of statistically significant results may introduce publication bias. There is another test, that is the Aspin-Welch t-test. This test is also is used as an unknown for the population means of unknown and possibly unknown population standard deviations. And a separate variance t-test is also used when unequal variances t-test is also, and also the Welch t-test. It assumes that both groups of data are sampled from Gaussian population or the normal, but does not assume that those populations have same standard deviations. We also uses the F distribution for the ANOVA, that is that is different from the normal distribution. Normal distribution is known as the T distribution, but for the F distribution, there are differences for the whole representation of the table. And in F table, the numerator degrees of freedom determines the columns, and numerator degrees freedoms. We calculate the degree of freedom, but we only use the positive values for the whole area. For only the is for the positive values, and it's not necessary that the whole area under the curve is equal to 1. So we find the rejection area. If the F stats is greater than F half alpha, we use an half alpha because we are only using the positive side of the curve. So we use A divided by 2, alpha divided by 2, and we use a F statistics. If the F stat is greater than the F alpha, then we do not reject the null hypothesis. And if we reject the null hypothesis if F stat is greater than F alpha, and we reject, in this case we reject the null hypothesis. This is the two-tailed and this is the single-tailed, and in this case we reject the null hypothesis if F stat is greater than F alpha. So the F distribution can be regarded as equivalent extension of the T distribution when there is more than one variable but the sample size is small. And there are numerous ways to introduce this distribution in literature. An F distribution is valid only for the positive numbers. For example, if the variances are equal, the ratio of the variances will equal 1. And for example, we use the ratio of variances. If you have a two set data with sample 1 variance 10 and a sample 2 variance 10, then the ratio would be 10 divided by 10 equals 1. So this was for the presentation. Now it's time for the MCQs. A group of 10 students were randomly drawn from class 12 and was given yoga training for 3 weeks. Their wellness lifestyle was compared with another similarity selected groups which did not undergo such training. Which type of statistical test would be appropriate for testing the null hypothesis? We have taken 2 groups, but one group has not taken such training. Any idea?
Beta.
A. Independent.
Yes, it would be alpha because we are considering two groups, and we are taking the numerical data. We are taking the interval with data on the interval ratio scale. So, and the one of the group has not undergone the training. So, independent t-test is the right answer. To test the to use the test, the dependent variable must have a nominal variable data, ordinal for both variables, that is dependent and independent are both ordinal, ratio or interval scale variables for the dependent variables, or confounding variables only. For the use of the t-test, the must have
B.
Beta. B. That's ordinal for both variables.
Actually, whenever we are using the t-test, we are using a ratio interval scale. We are not going for the ordinal scales for the chi-squares. For C is the right answer. T-test and other significant tests are frequently criticized. Over representation of statistical significance is research, which may result in which type of problem? Either it's publication bias, researchers fatigue, lost funding, confused graduate students, or increased impact factor of publications. Due to
Delta.
representation of statistically significant tests extensively using the t-tests.
Charlie. Lost funding.
It can be publication bias because whenever we are getting the statistical significant tests, then it might increase the publication bias. So A is the right answer. In order to examine the significance difference between any two small sample means, our researchers follows the R distribution, the F distribution, the T distribution, the CR distribution, or a Z distribution. In order to examine a significant difference between any two sample means, a researcher must follow.
Charlie?
Yes, it can be T distribution, but there is an ambiguity. It could be F distribution. I would have indicated more towards F, but C is the right answer, T distribution. In randomly constituted two groups, experimental and control, a researcher obtained the following results. The degree of freedom is 3. The critical value from the table is 2.3 at alpha level of 0.05. But the T statistic calculated value is 3, more than the table. And the total number of sample size is 300. So for these values, applying the t-test, which of the following decision is correct for the null and the research hypothesis?
D.
Yes, D is the right
That's
answer.
D.
Yes, D
Reject
is
the null
right
hypothesis
answer,
and accept
because
research.
whenever there is a value of t stat greater than the t critical value, then we reject the null hypothesis and accept the research hypothesis. Right. A researcher conducted a sample on students comparing means of science scores and math scores in a single group. It's a single group of sample size 5194. The mean of was higher for science score than the math score, and the differences are given here with the p-values. Which of the following tests is most appropriate to obtain such tests? Whenever we are using two means, comparing two means in a single group, and we are using the
Beta
yes,
pair
beta is
t-test.
the right answer. In this case, we will not use the independent sample t-test, we will use a pair t-test. In which of the following condition the independent sample t-test is not appropriate to generate accurate results? One condition is comparing the performance of individuals who either consumed coffee or did not. Two groups, comparing attitudes of Eastern and Western individuals. Two groups, comparing students' attitude change between start and end of their degree. Comparing men and women of IQs on one occasion. Again, two groups, comparing levels of aggression between group 1 who has experienced high levels with group 2, it was group 2 who remained calm. So in which case we will not apply the independent sample t-test.
Eta?
It would be C, where we are comparing the student attitudes between start and end of their degree. There would be a dependent sample t-test, so C is the right answer. Which of the following statement correctly describes difference between F and T distribution? The F distribution is discrete and T distribution is continuous. The T distribution is valid only for positive numbers and F for all real values. The F distribution is symmetrical and T distribution is skewed on the right. F distribution is valid only for positive numbers and T for the real values. And F distribution is skewed to the left and the T distribution is symmetrical. Correctly differentiates F and T distributions.
Beta. No, it's Charlie.
It's delta. The F distribution is valid only for positive numbers and T is for all real values. So D is the right answer. Which test would be used for this example? Comparing reading scores for a classroom of 3rd grade students to a classroom of 5th grade students. One sample t-test, independent sample t-test, variance test, dependent test.
Variance test.
Whenever we are comparing the mean scores of simple mean by using the t-test, we will use an independent sample t-test because we are comparing the students of between two grades. So we are considering two groups. Which t-test would be used for this example? Comparing students regarding skills from which they are in 3rd grade to 5th grade. One sample t-test, independent sample t-test, variance test, or dependent t-test, or the pair t-test.
Delta?
Yes, delta is the right answer because now we are only considering the single group of students from grade 3rd to grade 5th. So delta is the right option. This is the key, and thank you so much.
Thank you very much, Dr. Amber. Very nice presentation. But would you like to show me the YouTube link that you have presented on your thank you slide?
Ma'am, I forgot. I will add it on.
Right. And all the MCQs must have 5 options.
Okay, ma'am.
Otherwise, it is a good presentation. And I would like you to please share the YouTube link so that I can share it with all of my students in various classes. And they are giving us a very good feedback of these regular classes. And it is the essence of learning that we should share whatever we have the knowledge as well as the skills, and we should contribute to the existing knowledge. Thank you. Allah Hafiz.
Allah Hafiz, ma'am.
Thank you.